Welcome to my third video in my YouTube series on Connect4 neural nets. In the first video I showed how the neural nets were first trained using a minimax algorithm. In the second video I was talking about how the self-play was implemented in the main project. This video is just going to be about integrating some neural net functionality into an existing Django portfolio website that I had. So I'm going to be looking at what the page lets the user do. Basically the user can choose types of players and have them play against each other. So the types of players can be a human player, in which the user is responsible for choosing that player's move. The user can also choose a minimax algorithm. So as we can see here are the two players that the user will be using. So there's the human player option, there's the minimax algorithm option, and then the user can choose the depth of the minimax algorithm. They can choose the default neural net, so that's a neural net that I have hosted on the site, or a pair of value and policy neural nets that are used to drive the Monte Carlo tree search function. If you do a neural net option, you get this stochastic play flag. What that does is determine how the move is chosen. So if it's not chosen stochastically, that means that the move that is explored most by the Monte Carlo tree search is chosen. If it is chosen stochastically, then it means that they're chosen proportionally. So that play is less optimal, but it's also more varied. So the last option is the upload neural net. That means that the user can upload a neural net that they have locally, and as long as it meets certain specifications, as long as it can handle the board input, and as long as the output is in the right format, it'll work, and it will be integrated into a Monte Carlo search tree. So you still have those options available, the recursion count and the stochastic play count. I'm just going to do a quick tour of what it looks like using the site. So I'm going to do me playing the minimax algorithm of depth 4. So we load it up, and this is what we see. So here's our Connect4 board. The user uses these radio buttons to choose which column they're choosing as their move, and then if I click take turn, my piece has been placed. So now it's the minimax algorithm's turn. I can't choose my move, I just have to press take turn and watch it do its move. If you're not a fan of that, you can do autoplay, and now if I take my turn, it's going to do its turn automatically. So this is useful to speed it up, but also if you have two kind of bots playing against each other, whether they're minimax algorithms or whether they're neural nets, either uploaded or hosted, it'll function the same. So I'm just going to let the minimax win here quick, just to show what happens when a game ends. So we can see here that the minimax score has been increased to 1, and my score is still at 0, and I can either choose to play again or make some new players. If I choose to play again, now it's the minimax's turn to go first. Then I also want to show what the neural net stuff looks like. So let's do a neural net versus an uploaded neural net. So let's just choose those specifications, and I'm going to upload a neural net quickly. So I'm going to choose policy challenger and value champ, so we can mix and match it a little bit. Let's move the recursion count down so it works a little faster. And it takes a little longer because it's finding those neural nets, or actually saving those neural nets on the server. We have the same options here because there are bots available. We can just do autoplay. So let's take a. So there's two different options here. There's the autoplay like we saw earlier, where they'd be moving against each other, or there's back-end autoplay. So the back-end auto, the advantage of that is that the games happen on the back end. You don't actually see them happen in front of you, but because it's not loading and unloading all the time, it happens a little faster. So let's just do a quick 2 games there, and we can actually take a look on, because I'm running this locally, this is my local server, we can see the command window and watch that happen right here. So we get our showdown. So this is like the same code that we have in the head-to-head function that I was using in the Monte Carlo tree search stuff. And at the end we're going to get this like little output of the results of the game. So I expect, hopefully, the uploaded neural net should win, because I replaced this neural net. The default neural net used to be pretty poor, but I just replaced that recently. So we'll see how that goes. Player 2 is still winning. That one had a very low recursion count, so that makes sense. So that's pretty much the site after this completes, or at least like the user experience. You can see what's available here. So here's the output that we got. Player 2 swept. Amazing. So what I'm going to start looking at now is the code that's involved here. The front-end stuff I don't think is that interesting. You know, it's just handling what fields are available and making sure that the appropriate fields are available depending on who's there. So I think I'm going to skip over that stuff and just look at the Python views stuff. The rest of this is just like normal Django. You know, the views stuff is where it really is the stuff where the Connect4, the stuff that's related to Connect4 is happening. So if we look in here, we have our request method post. I'm using forms to post it in. So this first if statement checks if there is a board available. So if there's not a board available, it assumes that the game is new. So I guess that's the best place to start, is looking at a new game. So this function here, this is actually this is just checking the user uploads folder. That's where the user excuse me. It's in here, the user uploads folder. So it's saving the session name, and then it saves the uploaded neural nets. So I think that I have 2 neural nets that are uploaded here on this session, so that's why there's 2 in here. Because I guess that because I've uploaded as player 1 on this session before, so that's why that's there, even though I uploaded the player 2 neural nets just recently. But anyway, basically it checks if they're above a certain age, and it'll delete that folder if it is more than 24 hours. So anyway, so beyond that, we're creating our Connect4 board right here. We're just creating the vanilla empty board. What do we have here? There's such thing as a reset flag here. So there was that option there. If we were to do a game quickly, and we say play again, that's what triggers the reset flag function, so that's where this would go. So it holds on to, that's right, it holds on to the player scores, and it holds on to the autoplay count. So if you set a certain amount of autoplay games and it's played a couple of them, then it holds on to that data. If it's a new game, as it is here, you can see that it's just like resetting that stuff. It's resetting the player scores, it's resetting the autoplay count. So that's what that's for. Yeah. Okay. Then here is if it's a new game and we've chosen upload neural net, so this is where the neural nets are actually saved. So it's going for any of the files in the request. So the only files that can be uploaded are the neural net, the policy and the value neural net for the upload neural net option. So it's doing some basic checking here. It's checking if the name ends with value, then the output shape should be of type, should be a vector of length 3, and it gives this error if that's not the case. Likewise with the policy network, if the end shape isn't a vector of shape 7, then it raises an error. If that's all good, then it creates the session and it creates the path, and then it saves the neural nets. And then we return all this data. Here's our return render. So those of you familiar with Django will know what that's about, but that's I'm specifying here, I'm returning that request, I'm returning the HTML page that I'm going to be loading. So that's the second page that we saw there with the Connect4 grid on it. And then I'm doing all the variables that we need in that that we're keeping track of. So stuff like the legal moves available, that's important for if the human player is playing, and you need to know which radio buttons are available, the player turn, what type player 1 is, so that's when it says if it's a human player or a minimax algorithm. Whether or not it is the current player's turn, the board state. So we translate the board to an array. I'm not exact. It's been a while since I coded that function. The minimax stuff. Anyway, stuff like that's all saved, and so that's how we would get to here in our human player. So the only thing that's left to talk about in this function is how the moves actually work. So that is this thread here, if this if statement evaluates correctly. So if we do get a board state and the reset game flag has not been set to true, then we move in here. So we're getting some just variables that we need. So the board state, the legal moves, the player turn, stuff like that. And then we're doing our ifs, that figure out what type of player it is. So if it's a human player, this one's pretty straightforward. We're just reading a request post called the player choice. And we we scroll to that choice, and then we find the we iterate up through the available cells in the Connect4 board, and then we make that move, and we just return the board. That's basically it. Then we're checking if it's solved, we're checking if there's a draw, and then there's some other variable handling here. So if the auto count, if we're doing an autoplay function, so you can do when a human player is playing against either a neural net or a minimax algorithm using autoplay, that's when this is important. And we're just handling that stuff and returning it here. The rest of this is all grouped together, so if it's not a human player, then we go down here, and we're creating our board engine using the board state that was passed back from the request, and we have our legal moves. So the minimax algorithm is pretty straightforward too. We just build the tree, and then we get the minimax depth, and we build that tree, and then we can just serve the next state easily with the tree get move function, and we have our if is solved. So that gets the variables that we need from the minimax tree. If it's a neural net, the process is very slightly, but it's pretty similar. If we're using the default neural net, we're going to load the locally hosted neural nets there. And then if it's not, if it's the uploaded neural net, then we're going to be looking at our session, and we're finding our value neural net, and we're finding our policy neural net. In both cases, we're going to build our tree using those neural nets. So you can see here, we find our NN val and our NN pol, but in here we just take them directly, and I'm loading them inside the what is it called, the initiation function of the MC Monty tree. So in both cases we get a tree that's built with the neural nets that we wanted. Here it's like we saw in our head-to-head function. We just get the recursion count of the current player, and we're doing our selection. And then we get either our exploratory move if the stochastic variable is set to true, or the deterministic move if it isn't. Then it's a similar process to what we had above. We do an is solved, and then we're handling all those variables again, the player score, and if it's a draw, we increase the autoplay count and stuff like that. And that's basically it. Then it would skip through this else here, and it's using the same return. So that's just a quick overview of how the views PY on that page works using the standard moves. We can also take a look at the backend autoplay. I have this function here that loads the appropriate nets, the appropriate neural nets, and then we just use this head-to-head function here. And it's using the stochastic choices and the player 1, player 2, and eventually this is the table that we saw that returned those results at the end. That's basically it. That's all I want to say. I'm going to keep this video pretty short, but I just want to give an overview of how the back end of that page looks, you know, from a Python side, and how you can integrate all the stuff that we were using on our desktop locally, and how you can integrate that into an actual site and have it bounce back and forth interactively with HTML. So yeah, I encourage you to check the site out and test it with your own neural nets, and let me know how you find it. If you have any questions or comments about this video, leave them below, and I'll take a look at them. Thanks for watching. Bye.